All right, buckle up, because today we're diving deep into a company that's practically shaping the future, but most people haven't even heard of. ASML.
You're not kidding? They're kind of under the radar for how much impact they have.
Well, you sent over a stack of research on them, and I have to say, color me intrigued. Seems like you really want to get to the bottom of what makes this company so vital to, well, pretty much all things tech.
Exactly. ASML, it's this Dutch company, right? And they build these machines,
Yeah.
the machines that make the most advanced computer chips, like the brains of your smartphone, AI, you name it.
So no ASML, no powerful tech.
Pretty much. If they just vanished tomorrow, the tech world would be in big trouble.
Wow. Okay, that's a pretty stark picture. So in the pile of research you gave me, there was this really in-depth analysis called ASML, a deep dive.
Yeah, that one's packed with info.
It is, and it kept mentioning this thing, EUV lithography. Honestly, sounded kind of like sci-fi jargon to me at first.
I get that it does sound futuristic, but it's the real deal, and it's the reason we have such powerful gadgets today. Imagine, like, shrinking down super tiny and using light to etch these little circuits onto silicon.
Okay, I kind of get that, but
That's basically lithography and ASML. They're the only ones making machines that use this super special light, extreme ultraviolet, UV for short. It lets them make chips with parts smaller than 7 nanometers.
7 what? Nanometers? I can't even picture how tiny that is.
To put it in perspective, that's like fitting the entire Library of Congress on a postage stamp.
Whoa. Okay, I'm starting to get it. That's how my phone is somehow more powerful than, like, the computers that sent people to the moon, right?
Exactly. It's all thanks to those tiny, tiny circuits.
Mind-blowing. Okay, so let's talk about this EUV dominance. One report said ASML has something like 90% of the market for these machines. That's insane. How'd they get that kind of power?
Decades of really smart moves, honestly. They
Uh,
pour money into research and development. Billions of euros every year.
like how many billions?
We're talking over 2 billion annually. And they've got patents, like a ton of them, over 33,000 globally.
Wow.
But it's not just about spending. They've made some really clever acquisitions, partnered up with the right companies. It's a whole strategy.
Makes sense you don't just stumble into a near monopoly. But I'm guessing that kind of control means they can charge a pretty penny for these machines, huh?
Oh, yeah. Their EUV machines can cost over $150 million each.
150 million?
But chip makers are lining up to buy them because they need them to make the best chips. That's pushed ASML's value to over $250 billion.
They're in a whole different league. And speaking of those chip makers, the research kept mentioning TSMC, Samsung, Intel. Are they more than just customers? It sounds like they're almost partners.
It's a really close relationship. They're actually collaborating with ASML, investing in their development so they can get their hands on the newest tech.
So it's like a whole ecosystem.
Exactly. Everyone benefits from pushing the limits of what's possible.
Okay, so we've got this crazy advanced technology, near total market control, and this tight group of partners. But I'm still stuck on how this EUV magic actually works. One article described lasers hitting molten tin droplets in a vacuum chamber. I'm picturing like a sci-fi movie.
Well, that's pretty much how they make EUV light. Some seriously impressive engineering going on there. You need the light source, obviously, but then there are these insanely precise mirrors.
Okay.
Special masks to make the chip designs. A wafer stage that moves the silicon with like nanometer accuracy. Every little piece has to be perfect.
And they make all of this themselves, even those crazy mirrors.
Actually, the mirrors are where a key partner comes in, Carl Zeiss. They're a German optics specialist, been working with ASML for over 30 years.
Ah, so that's how they get those ultra-precise optics.
Exactly. It's a great example of how smart partnerships have helped ASML get to where they are.
I bet this level of precision means there are some serious challenges, though.
Oh, for sure. They need people with very specific skills to build these machines. Not to mention they use a ton of energy, and there are always issues with materials and precision.
Right, and we can't forget the price tag, 150 million a pop. But I guess the demand for ever smaller, more powerful chips is just that high.
It is. And on that note, one article mentioned something called High-NA EUV.
High-NA EUV.
It's like EUV, but even more extreme. It can make even smaller, more powerful chips. Imagine shrinking those circuits down to 3 nanometers.
Wait, even smaller than the 7 we talked about?
Yep. More transistors, more power. And it could actually make chip manufacturing simpler, even cut down on CO2 emissions.
Wow. So it's like the next big leap.
You could say that. It's still early days, though. The first systems were just installed this year. Wider adoption probably won't happen until 2025. Plus, the cost is still a big obstacle, and there are some technical hurdles to clear.
Like what?
Well, there's the complexity of the masks, for one, and then there are these things called stochastic effects.
Stochastic effects. Sounds a bit ominous.
Think of it like baking a cake. You use the same recipe, same ingredients, but sometimes it turns out perfect, other times it falls flat.
So these stochastic effects are like random variables that can mess up a whole batch of chips?
Precisely. Tiny particles, fluctuations in the light. These tiny things can cause defects, and that means lower yield, higher costs. It's a big headache for ASML, even with all their advancements.
So they might be on top of the world right now, but it's not all smooth sailing. What are some of the other risks ASML needs to be aware of as they look to the future?
The biggest one, geopolitics. The tensions between China and Taiwan, that's a major concern because Taiwan is home to TSMC, ASML's biggest customer.
Right, that's a tricky situation.
It is. Export restrictions could really hurt ASML, and there's always the possibility of retaliation.
Yikes. Okay, so geopolitics is a big one. Are there any other risks on the horizon?
There are always the usual suspects, supply chain disruptions, cybersecurity threats.
Right, those are serious for any company.
Especially one that relies on a global network, like ASML does. Then there's always the chance a competitor could catch up, or some new technology could come along and disrupt everything.
So ASML can't just rest on their laurels.
Nope. They have to keep innovating and adapting if they want to stay on top.
It sounds like their future is tied to some pretty complex global forces.
Definitely.
This has been a fascinating look at ASML, but we've only scratched the surface.
There's so much more to uncover.
We'll be back in the next segment to dig deeper into ASML's operations, their corporate culture, and some of the other challenges they face.
Stay tuned.
All right, I'm ready to get my hands dirty. Let's talk about how ASML actually makes these incredible machines. We've covered their financials and market dominance, but I'm curious about their operational side. How do they build these things?
Well, you're not going to find an EUV machine on an assembly line, that's for sure.
I figured as much.
Building one is like a massive undertaking, over 100,000 parts, all from different places around the world. And they're put together with tolerances smaller than a human hair.
That's insane precision.
It takes about a year to build just one machine.
A whole year. Okay, now I'm really starting to understand why they cost so much. It's more like they're building a spaceship than just a piece of factory equipment.
You're not far off with that analogy. And it's not just about putting the pieces together. ASML is always innovating, even with their manufacturing processes. Take their mirror production, for example.
Okay, yeah, those mirrors are crucial for EUV.
Right. They're incredibly delicate, need extreme precision. So they use robots guided by AI to handle them.
Robots.
Yep, robots. Minimizes human error.
Wow. So they're using cutting-edge tech to build even more advanced tech. It's a tech loop.
Exactly. And they're all about efficiency, too. Lean manufacturing principles, refining their processes all the time to make things better and faster.
I can imagine that takes a lot of discipline.
It does, but they've got it down to a science. They even embed their engineers with their suppliers to make the whole supply chain run smoothly.
That's smart. So it's this constant drive for improvement, always pushing for better quality, better efficiency. No wonder they're at the top of their game. But speaking of doing things better, one article mentioned ASML's commitment to sustainability. It seems kind of surprising for such a heavy-duty industry.
I know, right? You wouldn't necessarily think sustainable when you picture these giant machines, but they're actually leaders in that area.
Really?
Yeah, they've set some ambitious targets to reduce their environmental impact. By 2040, they want to hit net zero emissions across their entire value chain.
2040. That's a big goal. How are they going to manage that when their whole business is about making these energy-intensive machines?
It's a multi-pronged approach.
Hmm.
Energy efficiency, renewable energy sources, minimizing waste. They're tackling it from all angles.
Give me an example.
Okay, so between 2018 and 2022, they slashed the energy consumption per wafer for EUV lithography by almost 40%.
That's a huge improvement. So they're not just paying lip service to sustainability, they're actually making real changes.
They're serious about it. And it's not just the environmental stuff. They're focused on social responsibility, too. Diversity, inclusion, employee well-being, ethical sourcing practices, the whole package.
So they're trying to be a good corporate citizen, not just chasing profits. It's refreshing to see a company like ASML take these things seriously.
Agreed. They get that their success is tied to their employees, their communities, and the planet. It's that holistic approach that's becoming so important.
Definitely. Okay, so they're innovative, efficient, and sustainable. Anything else we need to know about ASML's operations?
Well, one thing they're dealing with as they grow is talent acquisition.
Talent acquisition. I thought they were a top employer offering great salaries and benefits. What's the issue?
They do, and they've got a great reputation. But they're expanding so quickly that they need to hire thousands of skilled people every year. Engineers, technicians, specialists. And the competition for top talent in this industry is fierce.
That's got to be tough. I mean, you can't just hire anyone to work on these multi-million-dollar machines.
Exactly. They need people who understand lithography inside and out, can solve complex problems, contribute to their innovation.
Right. It's a very specialized field.
And to add to the challenge, they're mainly based in the Netherlands,
Right.
which has a limited pool of qualified workers.
So how are they handling this talent shortage? Are they trying to poach employees from their competitors or something?
Well, that might be part of it, but they're taking a more proactive approach. Big investments in education and training programs, partnerships with universities, that kind of thing.
So they're building a talent pipeline.
Exactly. Long-term thinking. They're also recruiting internationally, offering relocation packages to attract people from all over.
So they're building a global network of experts. That's impressive. Okay, so we've got operations, sustainability, talent. What about ASML's overall company culture? What's it like to work there?
Well, one of the reports, 3 leaders in ASML history who made a difference, gives some really interesting insights.
Oh, yeah, I remember that one. It focused on their CEOs.
It does, and it shows how the company culture evolved over time.
Okay, I'm all ears. What kind of leaders shaped ASML?
Well, first up, there was Willem Maris, one of the founders and their first CEO. He was a true visionary, He saw the potential of lithography way back when it was still a niche thing.
So he was the one who set them on this path of innovation.
Absolutely.
Yeah.
He really encouraged risk-taking, thinking outside the box. Then came Henk Boot in the late 90s. He was more focused on operations, making sure they had a solid foundation for growth.
So he was the builder.
Yeah, you could say that. Efficiency, quality, customer focus, all crucial as they expanded globally. Then there was Peter Wennink, who led them from 2013 to 2023.
He was the CEO during a period of huge growth for ASML, right?
It was, and he was a real transformative leader, guided them through incredible breakthroughs, really emphasized collaboration, both inside the company and with their partners.
Sounds like each CEO had their own style.
Definitely. But they all shared some core values, a passion for tech, commitment to excellence, and respect for their employees.
That's a pretty strong foundation.
It is, and it still shapes ASML's culture today.
So what's it like to work at ASML?
Well, one article talked about their commitment to teamwork and knowledge sharing, which I found really interesting.
Knowledge sharing. A lot of tech companies are pretty secretive about their tech.
I know, right?
Right.
But ASML is different. They believe that knowledge should be shared. They encourage their employees to collaborate openly and learn from each other. They've got this whole internal knowledge management system, workshops, training sessions, all focused on sharing best practices.
So they're not just building machines, they're building a community of experts.
Exactly. And it goes beyond their own company. They collaborate with their customers, even their competitors sometimes, on industry-wide initiatives.
Collaborating with competitors, that's pretty unusual, especially in such a cutthroat industry.
It is. But ASML sees the bigger picture. They'll share their expertise to help move the whole semiconductor industry forward, even if it benefits their rivals.
That's a pretty forward-thinking approach. They're not just focused on winning, they're trying to raise the bar for everyone.
I think that's a big part of why they're so respected in the industry. They're seen as leaders, not just in tech, but in fostering collaboration and innovation.
That's inspiring. So to sum it up, ASML's culture is this blend of innovation, operational excellence, and a real focus on their people.
You got it.
Well, this has been a fascinating look at ASML's inner workings, their sustainability efforts, their talent strategy, their unique culture. They're clearly doing a lot of things right.
They are, but let's not forget the geopolitical stuff we talked about earlier. Remember, they're a Dutch company in a globalized world. One of the articles really dug into the complexities of those challenges.
You're right, we can't ignore the global landscape. We talked about the China-Taiwan situation, but what other geopolitical factors does ASML have to navigate?
One of the biggest is export controls.
Right, that came up before.
As a Dutch company, they have to follow EU rules, but they're also getting pressure from the U.S. government to restrict exports of their most advanced tech to certain countries, especially China.
Ugh, the whole U.S.-China tech rivalry. Everyone in the semiconductor industry seems to be caught in the middle.
It's a tough spot for ASML. China is a huge market for them. They've invested a lot there. But they also need to keep a good relationship with the U.S., a key ally and a source of innovation.
So they're walking a tightrope.
Exactly. Balancing commercial interests with geopolitical pressures?
Yeah.
Not easy. And it's not just China. They have to think about export controls and sanctions related to other countries too, like Russia and Iran. It's a constant juggling act.
Sounds like they need a whole team of diplomats on staff. How do they even manage?
Careful planning, strict compliance, and maybe a little bit of luck. They have experts who constantly monitor global politics and try to figure out what any changes in regulations or sanctions might mean for them.
So it's not just about building these amazing machines, it's about understanding this whole web of global relationships and rules.
Exactly. In today's world, technology and geopolitics are inseparable. It's not just about innovation. It's about power and strategic alliances.
That's kind of scary, honestly. Given all that, what can ASML actually do? Do they have any say in this, or are they just at the mercy of these global powers?
Well, they're not completely powerless. Their technological dominance gives them some leverage. They're the only ones who can make EUV lithography machines. That makes them pretty important to the whole industry.
So it's like they hold the keys to the kingdom.
In a way, yeah.
Yeah.
But they have to play it smart. Can't afford to anger key customers or powerful governments.
So are they just trying to comply with whatever regulations come their way, or are they being more proactive?
They're not just sitting back and taking it. They've been pretty vocal about how export restrictions actually stifle innovation, hurt everyone in the long run.
So they're speaking up, trying to have a say in policy decisions.
Exactly. They're trying to position themselves as a responsible global company. They're saying, hey, we're not just Dutch, we're global. We're invested in the future of the world.
That's a bold stance, especially for a tech company. Aren't they worried about backlash?
They are, and they're careful. But they also know that staying quiet isn't an option.
They have to be part of the conversation.
Exactly. The stakes are high, the future of tech, even the balance of power. It's all being decided right now.
This whole discussion about ASML and geopolitics has been eye-opening. It really shows how technology and politics are intertwined.
ASML is a perfect example of how globalization and tech are reshaping the world, creating both opportunities and risks.
And they're not just along for the ride. They're shaping the rules, advocating for their interests, working towards a more sustainable and cooperative future for the industry.
Definitely. ASML is a company to watch, not just for their tech, but for their leadership in navigating these complex global challenges.
I agree. Well, this deep dive into ASML's operations, sustainability, talent, culture, and the geopolitical landscape has been incredibly informative.
It has.
But there's one more crucial piece of the puzzle: their financial performance.
Right. Let's look at the numbers.
Yep.
How do they turn all this innovation and market dominance into cold, hard cash?
Let's get into it. What can you tell us about their financials?
Well, their numbers are impressive. We've already talked about their revenue being in the tens of billions of euros, but let's dig deeper into where that money comes from.
All right, let's break it down.
Their main revenue stream is selling lithography systems, both EUV and DUV. In 2023, they made about 21 billion euros just from selling systems.
Wow, that's a lot of machines.
It is. But they've got other sources of income too. They sell consumables and spare parts, the things needed to keep those complex systems running.
Makes sense.
That brought in about 4 billion euros in 2023. And then there's their service business, things like maintenance, upgrades, and training. That added another 2 billion euros.
So they're not just relying on selling those big machines.
Nope, they've diversified. It's smart. It helps them deal with market fluctuations and not put all their eggs in one basket.
Definitely a good strategy. Okay, so revenue is strong, but what about their costs? We've talked about how expensive those EUV machines are to build. What does their cost structure look like?
Well, as you'd expect, their costs reflect how complex their products are. Their biggest expense is the cost of goods sold. That's raw materials, components, manufacturing, all that. In 2023, that was about 13 billion euros.
That's a hefty sum.
It is, but again, it makes sense considering what they're making. And then there's research and development, can't forget about that. It's essential for staying ahead of the game, and they spent over 3 billion euros on it in 2023.
So billions going into staying on top.
Yep, but it's paying off. They're making big money and keeping a healthy profit margin. In fact, their gross margin in 2023 was 51.3%.
That's pretty impressive, especially for an industry like this.
It is. It shows they have pricing power, and their customers are willing to pay for quality. That margin lets them reinvest, reward shareholders, and keep their finances strong.
So they're doing well financially, but are there any risks to their stability that we should be aware of?
Like any company, they're not immune to economic downturns or changes in the semiconductor market. If demand for chips were to drop, it would definitely impact their sales and profits.
Right, the semiconductor industry has its ups and downs.
Exactly. And we've talked about how geopolitics is always in flux, which adds another layer of uncertainty. Export controls, sanctions, trade wars, all of that could affect their ability to do business in key markets.
So while their financial future seems good, there are some potential obstacles.
Definitely. It's a complex global environment, and their success will depend on how well they adapt and make strategic decisions to mitigate those risks.
This has been a really insightful look at ASML's financial performance. They're clearly generating a lot of revenue and maintaining a healthy profit margin. But as we've learned, there are some challenges out there that could affect their future.
It's a testament to their leadership that they've achieved such great results in such a competitive and volatile industry. They're a company worth watching, not just for their technology, but also for their financial smarts and how they navigate the global markets.
Couldn't agree more. Well, this deep dive into ASML's operations, their sustainability efforts, their talent acquisition, their company culture, and the geopolitical landscape they navigate has been incredibly informative.
Absolutely.
But there's one more aspect we need to explore: the ethical and philosophical questions surrounding their technology and its potential impact on society.
Right, we need to talk about the bigger picture.
We'll be back in the next segment to discuss those issues and wrap up our deep dives into ASML. Okay, we've explored a lot about ASML, their groundbreaking technology, their business, the financials, their global position. It's clear they're leading the pack in innovation, but all this talk about their power makes me think about the bigger picture.
Right.
What's the overall impact of what they're doing?
It's a good point. ASML is not just building machines, they're shaping the whole technological landscape, and that has a ripple effect on how we live and work, even how we think.
Exactly. One of the articles you sent, ASML, a monopoly on magic.
Oh yeah, that one's thought-provoking.
It really delves into those ethical and philosophical questions, a side of the tech world we don't always get to examine.
It's important, though. ASML's tech is enabling so much advancements in AI, autonomous systems. Those things have huge EE implications for society.
It's easy to get caught up in the excitement of new gadgets and faster chips, but we have to pause and ask, what are the consequences of all this progress?
Exactly, and that article raises some important questions about power. ASML has this near monopoly on EUV lithography, which gives them a lot of control over the future of chip making.
Right. We've talked about the business advantages, but what about the potential downsides? Could they use their position to stifle competition, dictate terms to their customers, even influence government policies?
Those are valid concerns. There aren't any simple answers, but the article highlights the need for transparency and accountability. ASML needs to be aware of its influence and use it wisely.
It's like that old saying, with great power.
Comes great responsibility.
Right. And it applies to companies just as much as individuals. Absolutely. And it's not just about ASML, it's the whole semiconductor industry that needs more ethical guidance, more scrutiny. Governments need to be involved too to make sure these technologies are used for good, not for harm.
Definitely a conversation that needs to happen. We can't just embrace every new advancement without thinking about the potential risks.
Right. Progress towards what? What kind of future are we building? Those are the questions we need to be asking.
Exactly. And ASML, being a leader in this space, has a responsibility to be part of that conversation.
They need to be talking to policymakers, ethicists, the public, making sure their technology is used ethically and for the benefit of everyone.
Absolutely. It's a chance for them to help shape not just the future of technology, but the future of the world.
Okay, so we've talked about the concentration of power. What other ethical issues did the article bring up?
Well, one that's becoming more and more relevant is the impact of these advancements on jobs and the economy.
Right, more powerful chips, smarter AI, that means more automation.
Exactly. And that could lead to job displacement across many different industries.
We're already seeing that happening.
It's only going to accelerate as technology keeps advancing. The question is, how do we prepare? How do we make sure everyone benefits from these changes, not just a select few?
Tough questions. It's a societal challenge as much as a technological one. We need to think about retraining workers, new skills, a more equitable economic system.
So it's going to take a collective effort. Governments, businesses, individuals, everyone needs to work together.
Okay, so power dynamics, job displacement. What else did the article highlight?
This is a sensitive one, but the potential for ASML's technology to be used for military purposes.
Right, the whole issue of export controls.
Yeah,
But this is about their machines being used to build weapons, not just consumer tech.
exactly. And it's a touchy subject, especially with the geopolitical climate the way it is. Tensions are rising. and the threat of conflict is real.
So should ASML be doing more to stop their technology from being used for military purposes?
It's a tough one. The article acknowledges that ASML is a business. They have a right to sell their products legally.
They can't be the world's police, right?
Right. But they also have a moral obligation to think about the consequences, to make sure they're not contributing to the development of dangerous technologies.
Another balancing act, commercial interests versus ethical responsibilities. It's something a lot of tech companies are struggling with.
Absolutely. There are no easy answers, but it's a conversation we need to have, and ASML should be leading the way.
Well, this has been a really thought-provoking discussion about the wider implications of ASML's technology and the ethical questions that come with it. They're not just making chips, they're shaping the technological landscape, which shapes our world.
Their story shows that technology is never neutral. It reflects the values and choices of the people behind it.
So true. ASML has this incredible opportunity and responsibility to use its power and influence to steer technological progress in a direction that benefits everyone.
I completely agree. It's a challenge that requires careful thinking, open discussion, and a commitment to putting ethical considerations alongside innovation.
Well said. Well, that brings us to the end of our deep dive into ASML. We've covered a lot: their tech, their business strategies, their financial success, the ethical dilemmas. It's been a fascinating journey.
It has. ASML is such an intriguing company, both for what they've accomplished and for the challenges they're facing. They're a perfect example of the complexities, the potential, and the risks of the tech world today.
We've given our listeners a lot to think about. I hope this deep dive has helped them understand ASML better, its role in the world, and the important conversations we need to have about the future of technology.
I hope so too. As tech keeps advancing, it's more crucial than ever to approach it with a critical eye, to ask tough questions, and to demand responsible innovation.
Couldn't have said it better myself. Thanks for joining me on this deep dive. It's been a real eye-opener.
The pleasure was all mine. Until next time.